Okay, here we have a pretty complicated looking problem where you have to use order of operations to evaluate the expression. We've got, first of all, over here, a big, huge fraction combination part. We call this actually a complex fraction. And then we've got a divided by and another fraction and then plus another fraction. So let's start with what can we do to make this a little bit easier. And the first thing you want to do is work on simplifying this huge fraction. Okay? Fraction bar, usually if you find any kind of operations being involved on the top or bottom of a fraction, you want to work on those first. I know what it says you're supposed to do PEMDAS for order of operations, but parentheses is kind of misnamed. It's actually saying anything with grouping symbols, and we consider a fraction bar to be like a grouping symbol saying, hey, do everything up top and up on the bottom before you move on. So that being said, we need to work on this part where it says 7/9 minus 3. Of course, you need a common denominator, so think of this as 3 over 1 and say, how can I subtract 3 over 1 from 7/9? Well, I'm going to need to change them both to a common denominator of 9. So let's times the top and bottom of this fraction by 9. And I'm still just working on the top of this main fraction bar, right? So what will that look like in the next step? Well, we would have 7/9 minus, and instead of 3 over 1, it's going to become 27/9. And we saw the 7/6 on the bottom. Divided by 3 over 2 plus 3 over 4. Alright, good. We have a common denominator here of 9. Now we can subtract. So 7 minus 27 is negative 20. Okay, so the next step is I'm going to try to squeeze it in here because I don't want to switch over to a new page yet. So that is negative 20 over 9. And then we have 7/6 on the bottom. And we're going to divide by 3 over 2, and then we're going to add 3 over 4. Okay, wow. So that still doesn't look too good, but at least we've gotten rid of a couple of terms on the top of the fraction. The next thing we might want to worry about is how do you do negative 20 over 9 divided by 7 over 6? Okay. So the next thing you want to do is remember that when you have divided by, like a fraction bar, that is the same as timesing by the reciprocal of the denominator. So the next thing we want to do is convert this into negative 20 over 9 times the reciprocal of 7/6. So let me grab the eraser here, and I'm going to erase some of this stuff up here so we have room to show our next step without losing what we've got so far. Alright, good. So we would rewrite that as negative 20 over 9 times, and the reciprocal of 7/6 is 6 over 7. And then we can keep the rest because we're not quite there yet. 3 over 2 plus 3 over 4. So the next thing is when you're looking at this part here, is there anything you can reduce by before you multiply? And that's always a good thing to ask. You look top and bottom of the fractions and see if they have any common factors, and if they do, you can reduce. And we see here that the 9 and the 6 have a common factor of 3. So let's reduce them a little bit by 3. This becomes a 3. 6 divided by 3 is 2. I don't see any other common factors though. 20 and 7. 2 and 7. 20 and 3. Nothing in common. So we can finish that part. And we get negative 40 over 3. Oh, sorry, 3 times 7. My mistake. So it's actually negative 40 over 21 divided by 3 over 2 plus 3/4. Alright, so let's make a little bit more space. Negative 40 over 21 divided by 3 over 2 plus 3/4. Okay, so the order of operations says that you need to do any divisions or multiplications before you move on to additions and subtractions. So the next part that we want to do is this part. But we've also learned that dividing by a fraction means to multiply by the reciprocal. So let's rewrite negative 40 over 21 times 2 over 3. And we'll keep the plus 3/4. Is there anything we can reduce here? 40 with 21, 2 with 21, 40 with 3, 2 with 3. I don't see any common factors at all. So I guess the next step would be to actually multiply them straight across. So we have negative 40 times 2, which is negative 80. And then we also have 21 times 3, which is 63. Check on your calculator if you need to. Plus 3/4. Okay, now we're just looking at the very last step. We need to add these two fractions. And as you know, with adding and subtracting, you need a common denominator. So we look at 63, we look at 4. Now, if you think of the factors of 63, 7 times 9, or 9 is 3 times 3. Do you see anything in 7, 3, and 3 that has anything in common with the factors of 4? Factors of 4 are 2 times 2. No. So the least common denominator is actually going to be 7 times 3, 3 times 2 times 2. So all of them, basically it works out to 63 times 4, which is 252. So what we're going to have to do is we're going to have to multiply the first fraction, top and bottom, by 4, and the second fraction, top and bottom, by 60. Alright, so one more time I'm going to erase and finish it up. Oh my goodness. Alright, so we take negative 80 over 63, and to build it up to a common denominator we times it by 4 over 4, and then we take the second fraction, 3/4, and we times it top and bottom by 63. And so we end up with negative 320 over 252 plus 3 times 63, 189 over 252. And so finally, when we add the tops, negative 320 plus 189. Let's see what that gives us. Negative 131 over 252. Alright, now the question is it fully reduced? And one of the things you can check for is on the bottom here, 252. If you add up the digits 2 plus 5 plus 2, you get 9. That means it's divisible by 9. It's also divisible by 3, because when you add up the digits of a number and it's divisible by 3, or 9, that means the whole number is divisible by that. But if you add up the top, 1 plus 3 plus 1, that adds up to 5. So that is not divisible by 3 or 9. So on first inspection, it looks like they're not divisible. But if you keep looking, you will find that 131 is in fact not common in terms of its factors to 252 in any way. So you can actually be confident to find out that this is the final answer.
Made with Doodlecast Pro.